Good afternoon. This is the week in review uh, video. Um, I was trying to do it for yesterday, June 4th, but I'm doing it for June 5th. Let's take a look at where you should have been working this week. So to do that, let's take a look at the schedule page, which has all of our exams, and it has a suggested schedule. If you look closely at it, here's a couple weeks ago. And here's where we are this week. And let's do a little close up on that. All right. Right after midterm one, to start the second module, you should have already started on lecture 8 in YouTube. Now, this week, we started with a mini lecture on absorption in infrared, and we'll talk about that in a few minutes. We went through a series of regular lectures 9, 10, and 12. Yesterday, lecture 13, and then, we were supposed to have this week in review video yesterday, but we got it today. And today, you should have been working on lecture 14. So let's get to the review. Uh, so the first video on the this schedule is not like required. It's a free country, so you can study any way that you like. This is just a suggested pace for you to follow. Anyway, so all these, different days for each, one lecture per day, roughly. You can do that, or you can, do it however you want. So the first one in the suggested schedule was absorption in infrared. And what we did was talk about the quantum fingerprints of water. Um, and as you recall, we talked about hydrogen in the first module. The diffraction videos in YouTube feature hydrogen and helium, and we can't do water because in the lecture hall, anyways, because it's infrared. We can't see it without night vision goggles, very specific ones. But anyways, we talked about the fact that water doesn't do a lot of transmission of light through liquid water at this particular wavelength. So it doesn't, it's like, here it is. It's down at zip zap. And that's at about 3,000 uh, nanometers. So we talked about that, and that's one of the quantum fingerprints of water. And when we're looking for water in the cosmos, yeah, that's one of the things that we look for, the 3,000 meter absorption feature, where light, from a background source is getting absorbed at this specific wavelength. In that lecture, I also challenged you to use the study tool, the search box in the textbook, to look up just the general word absorption. And there's tons of things that you can see when you use a search box like that. And I'll just mention, you can use that search box for any other term that you want extra reading on, or something that intrigues you. Hold on a second. Uh, Something that intrigues you. My wife's cooking in the kitchen, so you could hear her messing around in there. Anyways, yeah, this is a good study tool. So you can use it to embellish and amplify your notes. Lecture 9. And we're using it for Summer A 2021. And we talked about Mars, or I talked about Mars quite a bit. And here's some of the absorption lines or absorption features for CO2. Okay. And this is CO2 ice. And you can see some big dips in the transmittance, or actually, I think this is reflectance. Um, and that's quantum fingerprints for CO2. So we talked a lot about that because, identifying the composition of the atmosphere, the composition of the surface of Mars, Finding CO2 and finding water ice is pretty important. It's a big thing, that we want to know about. And so that was in lecture 9. We talked a great deal about volcanic activity on Olympic Mont. Well, it's not really active right now, but at times in the past, yes, it has been, and it's a gigantic volcano, bigger than any volcano on Earth. And we compared it to Earth. We compared it to Hawaii, and we talked about Yellowstone, various other volcanoes, and which are teeny. The Olympus Mons is about as big as the state of Arizona. And my TA told me that when Hurricane Irma a few years ago was at its biggest, I think she said it was a little bit bigger than Olympus Mons. So Olympus Mons is pretty gigantic. All right. Now, one of the other things that we talked about was up in one of the regions of the Tharsis hemisphere of Mars, we found a place called Nili Fosse where um, we think we have spotted seasonal plumes of methane in the atmosphere. Right now, currently, they're disputing that. Some people say it wasn't really a true, it wasn't a really true methane plume. It was something else. Anyways, we're looking at it real hard, and it's a good description of why we try to get quantum fingerprints of as many things as we can, whether absorption or emission spectra, because we want to know about stuff like methane, right? And the fact that, if we do find a place on Mars where there really is a solid seasonal or, continuous emission of methane, we're going to think, okay, that's a good place for us to go looking for life on Mars. Right? We're concerned about water and we're concerned about life on Mars. We want to find both of them if we can. And we close the lecture with a short discussion of this famous meteorite, ALH 84001, discovered down in Antarctica back in the year 1984. And they think that it was, when they took a cross section of it and they looked under an electron microscope, they found something that looks like a worm. So they think, oh, this is a very, very small fossilized life form. And that's under discussion too. Not everybody's sure that this photo shows a life form. So we're putting rovers up there. We're trying to, build up our knowledge of Mars, and hopefully, we may find some other life form or fossilized life forms. So there's a lot to learn up there on Mars, and we might even find life, deep in the under the surface, and cracks and stuff. Lecture 10. Again, we're using it this summer. And one of the first things that we did in Lecture 10, we went over something concerning Mars, and that's the density of Mars. We worked through a bunch of numbers, uh, and the basic formula for density, rho, mass divided by volume, and we calculated it out for Earth compared to Mars. And we're comparing a lot of the planets to Earth simply because we know a lot about Earth. And so it's helpful to always compare things. You wouldn't want to compare a star to Earth, but if you see planets, yeah, you want to compare planets to Earth. And we got a bunch of them in our solar system. Another thing that we did in Lecture 10 was we talked about the absolute temperature scale. It's fairly basic instruction. It's a different temperature scale than Celsius and Fahrenheit. And it's the one that we normally use in most of astrophysics. So we don't really use centigrade or Fahrenheit too much in astrophysics. Okay, so that's a good one to make sure you review that. It's very basic. All right. Then we talked about Venus and all the different things happening. that we've observed on Venus. Here's the famous Venus probes, the Venera series that the Russians, the Soviet Union, sent up, back in the day. So this is, 40, 50 years ago. And, I discussed how the conditions on Venus, like sulfuric acid, rain, extremely high pressure, atmospheric pressure, made it very difficult for these spacecraft to operate. The longest running spacecraft that landed was 127 minutes, so it's a pretty hostile place. So we talked a lot about that and how then that brought us to the topic of tectonic plates, and I reviewed a little bit of that with you in the context of Venus and, of course, the context of Earth. So um, now, lecture 12, you should have, studied that this week, hopefully already. And what we did was talk about Mercury quite a bit. And one of the things on Mercury is something called the Caloris Basin. It's an impact crater that's been filled over with lava from the original impact. And it's about the size of this big red circle. And so it's enormous. And we don't think that currently Earth has any impact basins of that size. All right, now, early in the history of the Earth, a crater that size might have formed, from something that, like something like what happened to Mercury. But all the weather and stuff that erodes the Earth and changes the surface, all the craters have worn away from that era. Now, this is a circle the size of the Caloris Basin centered at UCF in Florida. And for comparison, in this lecture, I also mapped in the impact crater that we can see down in the Yucatan Peninsula at a place called Chicxulub. And this is the crater we think extinguished the dinosaurs 65 million years ago, approximately. All right. And for Earth, that's a big impact crater. And it's not a planet killer, but it was definitely an extinction level event for many, many animal species, like the dinosaurs. But you can compare it to the size of the Caloris Basin, and it's nothing. It's a very small fraction of the Caloris Basin. So, so I invited the students in that lecture to think, what would happen if something hit Earth like the size of what hit Mercury, and Mercury is a smaller planet too. And so it's a big, big fraction of Mercury that was, where that impact basin was formed. And on Earth, it would be pretty big too, even though Earth is so much bigger than Mercury. It would just, I'm not sure that would be a planet killer, but boy, it would sure rearrange the furniture quite a bit. Another thing that we talked about was in this lecture was Jupiter, and some of the stinky chemicals that we know from Earth, like ammonia. We know that's hydrogen sulfide, and all these. We could see the quantum fingerprints of those in the atmosphere of Jupiter and Saturn. And so we talked about that a little bit. And we talked about an important analogy, the pillows analogy, which is illustrated in this diagram, where it shows how additional mass tends to compress everything below it. Now that makes common sense to you, but it shows up in what we have observed from Saturn and Jupiter. We've had many spacecraft fly by. We've had many spacecraft orbit. We've even sent a few probes down into the atmosphere. And so we know what the conditions are like in there. and we could get a rough picture. It'll improve over the years, but we know that for instance, the presence of metallic hydrogen in the core of Saturn and Jupiter is different, and it's explained by the pillows analogy. We talked about weather on Saturn and Jupiter, and we compared it to Earth's atmospheric pressure. And we started talking about the moons of Jupiter in this lecture. Now, in lecture 13, this is going to be the last one that I'm going to review. We continue to talk about the volatile chemicals and why they're helpful for studying the outer planets, comets, and asteroids. And we then talked about the spec sheet for Saturn at the Space Science Data Center, NASA's Space Science Data Center, the planetary fact sheet. And we took a look at that stuff. We talked about Saturn. And then we turned our eyes toward the moon Enceladus, one of the moons of Saturn. And it's an interesting moon. It's only about the size of Florida, so it's not a super big moon. It's hard to see from Earth. But we've had the Cassini spacecraft up there. We had it up there for about 20 years, I guess. 10, 20 years, observing things on Saturn, taking photos of everything. So we know the size and the mass of Enceladus very well. And what we found is that there's water geysering out of the southern hemisphere of Enceladus. And so we've been trying to figure that out because, as always in the solar system astronomy, we always want to be alert for the presence of water, and we found it in this small moon. And in this lecture 13, we talked about the tidal forces that kind of cause Enceladus to flex and generate heat, kind of like when you rub your hands together. It's friction. And that generates just enough heat to cause geysering of liquid water. So it's pretty interesting. We talked about tidal forces in general, and we will talk about tidal forces in future lectures. And you can read about, so go to the search box in the textbook and type in the word tidal or tide, T-I-D-E, and just read about what it shows you. Okay, because there's a lot to learn. We talked about the Shoemaker-Levy impact, the comet impact on Jupiter about 27 years ago, which was big news at the time. So that's about it for lecture 13. Now, to finish the week today, you should be on lecture 14 or so if you want to follow this schedule. And but look to next week. We've got midterm exam 2 on Thursday. There's lecture, so you got lecture 14 ahead, lecture 16, and lecture 17, and then the midterm. Okay, and you have a study day worked in there on June 9th, and that's when the homework is due at 11:59 p.m. And then the next day, June 10th, midterm exam 2. All right. Now remember, when you're looking at the video in YouTube, they had a completely different exam schedule, and they had homework scheduled different and stuff. They had clickers, which we're not using, of course. So bear that in mind. So just kind of tune that stuff out and tune your mind into this schedule. This is the master schedule for the semester. Okay, that's it for the week in review, and I hope you have a good week next week. We'll have some office hours on Tuesday and then again Thursday night.